when you're trying to apply the regular exponent laws. So in this case, multiplying means adding exponents, but your exponents are fractions. How do you go about that? Well, in this case, it means that you would have to add these fractions. And how do you do that? Well, adding fractions means you need a common denominator. So in this case, my common denominator would be 15. I'd have to multiply this by 5 over 5, and this one by 3 over 3. And then once I have a common denominator, adding fractions means I add the numerators and keep my denominator the same. If you have a scientific calculator, it has a fraction button. And if that is the case, you could add 5. Usually the button is ABC or something like that. 5 ABC3 plus 6 ABC5. And you want to make sure that your final answer is written as an improper fraction, which is kind of a weird name because it's actually the more proper one. It's the one we use in math. So that's my final answer. Going about the regular exponent rules using fractions just means you have to remember how to add and subtract fractions and how to multiply fractions. Reminder, multiplying fractions means you multiply numerators and multiply denominators. No common denominator is required for multiplying. Okay, the one thing that is new is that the same way that you can't have a negative exponent in your final answer, for fractions, you can't have a fractional exponent in the denominator of an expression. So as a final answer, this is fine because that's in the numerator. This negative means that I have to move to the denominator. This is not okay. I can't have a fraction in the denominator of a final answer. So how do you go about fixing that? Suppose you had a final answer like this. You simplified everything. This is what you get down to. You have a fraction in the denominator. The way to fix this isn't to just bring it to the top, because if you did, it would have a negative, and you can't have a negative in your final answer. Instead, what you need to do is you have to bump up this exponent to be a whole number. How do you do that? Well, to bump this up, we need to multiply, because multiplying exponents or multiplying powers means that we add exponents. And I have to multiply it by something that will make this a whole number. And the other part of this that's a little bit different is that I need to multiply the top and the bottom by the same thing. Why? Well, I have to make sure that this thing that I'm multiplying by is equivalent to 1, so that it's still overall equal to what I started with. So I picked 2 over 3 as my exponent. The reason that I did that is because I know that when I add 2 over 3 to 1 over 3, it will add up to a whole number. Generally speaking, what I need to do is look at the fraction that I have and the denominator of that fraction. To get a whole number, I have to have multiples of that denominator. So 3 over 3 is a whole number, 6 over 3 is a whole number, 9 over 3 is a whole number, 12 over 3, etc., etc., multiples of 3. What I need to do is then look at this numerator and figure out what is the next closest whole number, the next closest multiple of my denominator. In this case, the next closest multiple of 3. And in this case, the next closest one is 3. So I add this 2 over 3. By add, I mean that I'm multiplying, which is going to make me add exponents. And on top, my numerator, when I multiply 5 times x to the 2 over 3, I'm just left with 5 times x to the power 2 over 3. And at the bottom, when I add these up, I get 3 over 3, which is 1. And remember that when you have an exponent 1, you don't actually write it. So this is my final answer. It doesn't look simplified because I have x's on the top and the bottom, but that's what this new rule is that you can't have a fractional exponent in the denominator. We'll try another example. In this case here, my y is fine. It's in the numerator, and I'm allowed to have a fractional exponent in the numerator. It's just the denominator one that isn't. So I need to multiply by a certain number of a's, top and bottom, to bump this up to the next whole number. And remember that by whole number, I mean to have multiples of 4. So 4 on 4 would be a whole number. 8 over 4 is the next whole number. And that means that I need to multiply by 1 over 4. That's going to bump this up to 8 over 4, which I know is a whole number. It's actually 2. In my numerator, I have these 2 different bases, so they just get stuck together. Y to the power 4 over 5 times a to the power 1 over 4. And down here, I end up with what I can write as my final answer, just a2. You don't have to necessarily show this step. I'm just showing where it came from. So suppose you had something like this, a problem with a whole bunch of exponent laws and a whole bunch of fractions. This is what I recommend doing. Step 1 is to deal with any exponents that you have raised to exponents. So this rule here, I'll make this, remember that when I'm multiplying by 4, it's like 4 over 1. Multiplying means I multiply the numerators and multiply the denominators. Optionally, you don't have to do this step, but it might be less confusing if you move around all of the negatives next. So any negative moves from the top to the bottom or the bottom to the top. That's what I did here. I highlighted them in blue, the ones that I moved. And once I get to this point, now I can combine together all of my x's. These two combine through a multiplication because they're next to each other, they're on the same line. And this one is a division. So I'm going to add these two and subtract this exponent. So to do that, because I'm dealing with fractions, I need to have a common denominator. I made all of my x terms over 3 and my y terms over 4. So I'm going to do 3 plus 3 minus 16, which is going to give me negative 10, which is why it ends up at the bottom. And down here, when I multiply these two that are at the bottom, 6 over 4 and 5 over 4, when I multiply those powers, I add their exponents. This is what I end up with. And that is almost done. But remember, what I need to do is I have to end my problem without any fractional exponents in the denominator, which means that I need to bump this up. For the y's, the next whole number, because I have to go by 4s, this is an over 4. 4 on 4 is a whole number, 8 on 4 is a whole number, 12 over 4 is the next whole number. So I need to bump this one up by multiplying by 1 over 4. And for my x's, powers of 3 or multiples of 3 would be 3 over 3, then 6 over 3, then 9 over 3. The next one is 12 over 3 is the next whole number. So that's what I need to add these two to get up to 12. In my numerator, both of these terms stay. When I multiply through this is what I get. So I'm going to move this out of the way. That's weird. It's blocking the actual answer. So what I end up with is the x to the 2/3 and y to the 1/4. Those stay there on top. And these get bumped up to their next whole numbers. X to the power 12 over 3 is really x to the power 4, and y to the power 12 over 4 is really y to the power 3. And that's how you end your answer.